Welcome back to Stories in AI. Today I speak with Daniel Jeffries. He's a professional author, blogger, a futurist, an expert in AI, data, crypto, and many more. He's also the chief evangelist at Pachyderm. We had a fun conversation. We talked about the state of AI and crypto today. We talked about life in 2030, mental models to predict the future, a canonical stack for AI and machine learning for enterprises, and of course, crypto and many more. I really enjoyed this conversation, and I hope you do too.
Daniel, welcome to Stories in AI. How you doing?
Fantastic. Thanks for having me on. Most appreciated.
That is awesome. No, thanks for taking the time. Tell me your story. How did you get into AI? And you're not just AI, you're a lot of different things. So tell us your personal story.
I mean, AI, when I was working at Red Hat maybe 4 or 5 years ago, I started looking around and thinking like, Red Hat's an infrastructure company. Why aren't we doing this? And so I wrote this giant 50-page manifesto on how we should get into AI infrastructure. And I started working groups and socialized it up to the CTO. And it didn't happen at the speed that I wanted it to, right? And that's Red Hat, amazing company. I was super excited to work there, and I spent almost a decade there. But at some point in time, I just felt the need to get back into kind of like the startup space because I knew it felt the same as kind of the early Linux days and the early internet days. And I'd ridden both of those waves, but I was too young to really do anything but surf the waves. And now I'm old enough, have a tiny bit of wisdom and a few connections, and I felt like I could at least shape some of the winds as well. So I wanted to get back into it full stream and just sort of dedicate the next decade of my life to it.
That's awesome. Before we go more into digging into AI and tech and future and stuff like that, you've been a digital nomad for some time now. Tell us about that experience and what did you learn from it?
Oh man. And so there's self-reliance, I guess, right? You learn a lot of things about yourself when you put everything into a single suitcase and you live off of that and you don't even have an apartment to fall back to. So I did that for about 2.5 years before Corona brought that to a crashing halt. And then I ended up in Europe because I did a little math on kind of who was going to screw up the pandemic worse, the United States or or Germany, and the math wasn't that hard at the time. Luckily, in America, we do what we do best, and we throw a lot of money at the problem, and we turn it around, and so that's it's looking strong there. As Churchill said, Americans always do the right thing after exhausting every other possibility. So that's
or in other words, as Warren Buffett says, never bet against America, right?
never bet against America. They always pull it out in the end, man. But yeah, look, the thing about it is when you're traveling the world and you're seeing all kinds of different cultures and you're living there for longer periods of time, you just get an expanded perspective, right? When you're only in the same place your whole life and you never come across any divergent ideas or cultures or ways of doing things, you make the mistake of thinking that your little point on the sphere of knowledge is the only point, right? So I always say the sum totality of knowledge is a sphere and nobody can see it. And we're all just an individual point. The worst mistake that you can make on there is to assume that individual point is the whole sphere. Many people do that. So traveling, reading great books, like talking to other brilliant people, studying, developing a flexible attitude gives you other little points on that sphere of knowledge. And you'll never be able to see the whole sphere, but you might get a better outline of it. And I really think when you experience other cultures, my greatest teacher always told me that education is what you are exposed to. And if you're only exposed to a limited amount of things, your scope of knowledge can't hope but be, very narrow, right, and short-sighted. And to me, that's all the cause of many of the problems in the world today. When I look at it, if we just taught kids critical thinking, a single class on critical thinking. I'm not sure we could find the teachers to do it, but pretend that we could. If we taught kids just one class on critical thinking and how to not take everything at face value, I think society would be radically leveled up in a very short period of time. But it hasn't happened, and it generally doesn't happen. It's generally we're taught what to think, not how to think, and I wish that would change in the world. Travel can do a little bit of that for you.
No, I totally agree. I mean, like I've lived in 3 continents. I grew up in India, spent a lot of time in Europe as well, and been Austin has been the place I've lived the longest ever in my life, other than where I grew up
Mm.
back in South India. And you're right, exactly. It expands your perspective, kind of gives you like the most people have the the idea of their knowledge being what you don't know, right? I mean, it's that perspective that it gives if you travel and sample yourself. Now, I must say the coronavirus pandemic and the digitization acceleration now offers an opportunity for everybody to really kind of expand their horizons through connecting and talking to people through Zoom, through digital things. I know it's not the same, but at least one additional opportunity for everybody to expand their horizons, right? So, talking about divergent thinking and thinking about getting perspectives and collecting those perspectives from around the world, you call yourself a futurist, right?
Mm.
What does that mean? And tell us about what are you thinking about?
I mean, a futurist is just someone who studies patterns, right, and tries to take an agnostic view of them. And you look at life as as a system, right, and everything is a bit of a system, and everything is a game, right. And if you can understand the system, right, then you can kind of do a Monte Carlo analysis of the future, right. So what you can't do is predict pure black swan events. You can't predict, like, you might know that there's a pandemic or a war at some point, but you can't actually predict the timeline of said
Yeah.
things. But right, and you can't predict a game-changing technology like when the printing press gets invented or the internet, right? It fundamentally changes everything in how we do things. What you can do though is kind of look at all the various trends culturally, socially, technically, right? And you can do this Monte Carlo analysis. You can kind of project out into the future and say if all these atoms are bouncing around, all these particles are bouncing around and interacting with each other, there's going to be stronger branches and weaker branches of how this potentially plays out. And for me, I've always thought about things as a system. I've always thought about the big picture of how it all fits together. I'm always projecting into the future. A lot of people don't, right? I think most people are very much wired to live in the present moment. And I think from an evolutionary standpoint, that made sense, right? If you didn't worry about too far in the future, because if you heard the tiger in the bushes, it didn't make any sense for you to not believe the tiger in the bushes. Everybody who didn't believe the tiger in the bushes is dead, and everybody who believed it is there. The challenge is now we live in this super interconnected world where we get a whole chunk of information that is either deliberately false or not fully formed in terms of its thinking. And so we can't just believe our own senses, right? And so again, it comes back to that critical thinking. You have to kind of look at all of the little things that are projecting out in the world, and you have to be agnostic to it too. You have to kind of step outside of your own self and your own belief systems and try to look at it as like somewhere in between, right? Look at it as something where you take all the different perspectives into account, conservative, liberal, and everything in between, right? You take into account people you disagree with, right? People who you radically agree with, right? And you try to figure out where you're wrong and where you're right, and you just keep projecting out into the future. And I think it's a skill that served me very, very well in life, right? I mean, it's helped me kind of predict trends and go into that in my career, right? So like when I first went to work in the internet, people told me I was crazy. They're like, "Why would you do this? This is just a stupid thing where people play games and like send text." And I'm like, "No, you don't understand. This is like a game-changing technology. It's like there'll be libraries on there, and people will read books and papers on there, and we keep mass communication." And people are like, "What? Stop! Like, it's ridiculous." And the same thing happened with Linux, right? When I started looking at Linux as an early IT administrator, I was like, I want to go work on Linux, and people thought, oh, my recruiter told me, man, all the jobs are in Solaris, and I said Solaris won't exist in 10 years, and he looked at me like I had three heads, right? So from my standpoint, it's really helped me kind of predict sort of future events because I'm constantly projecting out in the future to see how things will go. And that's why I got into AI, because I'm seeing the same patterns again and again, and those big patterns repeat over and over if you just open your eyes and look.
Now, is there a mental model you use to actually do this, or is it like a combination of different things? For example, you said you look at the conservative perspectives, the liberal perspectives, people you agree with, disagree with. But then how do you actually play this out? Is it trends and you project those individual trends into saying, how does it all confluent together in the future? Is there a mental model you use to do that?
So, I mean, look, at this point, I'd say it's unconscious competence, right? And so like it all blends together into me just sitting down at a page and writing out a lot of ideas. So if I'm particularly interested in it, the creative process is exactly the same, right? You sit down and you do a rough draft and you keep thinking through all the ways that it could play out, right? So it's to me, it's no different than writing, right? Writing is the bedrock of everything that I do in my life, right? I write every single day. I've been doing it for 20 years. And for me to kind of sit down and journal through these things or write articles or things, it helps me get my thoughts solidified. Like, and I had an old teacher who said, you can't think outside of paper, right? And I find that to be very true, right? You can kind of get the pieces, but you really have to be more structured when you put it down. Now, I will say that there are a whole bunch of techniques I tend to use over time, which is looking for abstract patterns, right? So one of the things I always talk about, probably one of my favorite books is Super Thinking by the fellow who started the DuckDuckGo thing. Him and his wife put this together, and he cataloged all these beautiful mental models for thinking about the world. It's fantastically written. I'd recommend it to everybody for like leveling up your thinking. But for me, I would say I look for categories of information rather than individual iterations of information. So this is what tends to happen when people are trying to do futuristic projections, right? They mistake the iteration for the category. So what is a category? A category is home video recording. Betamax, VHS, DVD, Laserdisc, Blu-ray, DVR are iterations of that technology. Mm-hmm. What happens is most people laser in on the iteration and they see the flaws and the pluses of it, and they project those flaws out indefinitely into the future as if they'll never change, right? And so like someone looks at Bitcoin and go, well, it's 10, it's only blocks every 10 minutes, and it's really slow, it uses a lot of energy. This thing is total nonsense, it'll never work. What they can't do is look at it as an abstract category and understand that each generation progresses over time. And that the engineers are always working on solving one problem, the next, and they open up doors as they solve one problem, and it moves forward through time, right? So the problem is you can't mistake the iteration for it. But once you start understanding like what is the category here, and then what would the projection be through iterations? In other words, I can't predict the Kindle itself, but when I looked at something like CD-ROM books back in the day, mm-hmm. Okay, I thought, well, digital books are going to be amazing, but there's a bunch of stuff that's wrong. Like this is easily scratchable. I could lose the thing. It's really clunky. It's sitting on this giant computer. I'm not going to carry this around on the subway. So I can't predict precisely what the eventual winner will look like, but I can say, look, it's going to have to be really compact. It's probably going to have to be book size. It's probably going to have to hide away the media. It's probably going to have to store a lot more books. In other words, it's going to need to have more advantages than the current iteration of text, which is 1,000 years old and works really great. Right. But now that so you can predict it's got to be easy on the eyes, right? It's got to be compact. It's got to have a long battery life, right? And so you can start to see like the generations kind of develop. You can identify what the problems are. And once you start to say, okay, imagine if someone solved this, this, and this, what would that kind of look like? Right. And that's how you start to get a sense of it. The same thing when you look at artificial intelligence, people go, well, it's really narrow. It only does one thing. Of course, but like, there are people out there working on universal intelligence algorithms. There are people working on transfer learning. There are people working on, automating the data sets, augmenting the data sets. There are, all these kinds of research is happening. So you can start to project out and imagine what it'll look like if we solve you list all the problems, you start to imagine what a solution would look like. It's what they call it unobtainium, right? If I had unobtainium and I could solve X, Y, A, B, C, D, and Y would be solved, right? And that's, to me, so if I deconstruct how I do it now, it's been a long time since I've formalized the process, right? And it's unconscious competence. I've been doing it for so long that it feels like as natural as breathing. But if I deconstruct the process back to what I'm doing, that's the general model.
I love it. I think I love the way the mental model you're providing. It's like, don't look at the iterations, but look at the categories, right? So then, yes, you got to look at the iteration to study where the category is at, but then make the bets on the categories and not necessarily the iterations. It's almost like, right. If you're not like, why crypto enthusiasts are bullish on Bitcoin, if you think about it, right? Bitcoin is an instant, it's an iteration that is happening today, but the overarching crypto market is what is going to drive the value that everybody's believing it will. So play out this model, that you use this model, and you wrote some amazing articles on 2030, AI in 2030, crypto in 2030 and stuff. Mesh it all together. Just lay out the world in 2030, a couple of things that we should think about.
So, the question, so I always try to be careful about, so 2030, the reason I wrote that article is we were writing it for CoinDesk, and they were thinking about the next 10 years, right? So I picked an arbitrary date. I want to be very careful of the dates, right? The one thing you kind of always get wrong is plus or minus 5 to 10 years, right? Or 30, right? So let's just say, though, what you can do is kind of figure out the broad strokes of it. I would say there's a push towards really refining and productionizing the narrow instances of artificial intelligence. And you can do a lot of amazing stuff with that. Right? You can drive cars and boats, and you can translate text, and you can recognize things in images, and they're going to really refine that. You're going to get a canonical stack of AI infrastructure, or you're going to get a lamp stack of AI infrastructure that's going to take it out of the research labs, the big FANG companies, right? And it's going to allow regular enterprises to kind of like hire data scientists, and then it starts to move up the stack, right? And you start getting little narrow AIs in every single application, right? Everything that's living on your phone and everything else there. The next thing, though, is you start moving towards more kind of universal algorithms, or algorithms that can do more than one thing. And there's kind of two paths that I see to that. One is that there's just a breakthrough, right? Somebody who's like a mental model researcher, a brain researcher, a AI researcher, or some combination of group of the above, is looking at trying to decode the black box of the human mind and to get our sort of universal algorithms. And what humans do really well, right, is abstraction, right? So they take what I'm doing at a totally different level. So when you train a narrow artificial intelligence, you might train it on knives and it might understand the concept that a knife is dangerous. You might show it a million knives. But when I get cut once by a knife, I can see something else that's jagged, and I abstract the concept of sharpness to that. I don't need to be trained on that rock to know that thing's going to cut me too, right? Yeah. So there's somebody out there studying those kind of abstract reasoning problems, and we'll probably see the mesh of kind of the old school symbolic reasoning. Even Jeffrey Hinton is talking about that, right? Where the capsule networks, where you teach it a little bit of geometry and then plug that together with the content, and all of a sudden we don't have the processing power to do it, but the processing power is going to dramatically accelerate, right? You get NVIDIA and Taiwan, Semiconductor, and all these groups, Google, everyone working hard on this, and the processing accelerates, algorithms develop. I think there's also a third pass to this, right? So these universal learning algorithms that get us to a point where they start abstracting out knowledge, extracting concepts. That's where you really start to get intelligent machines. From my standpoint, though, there's a possibility we just hack it. And there's a ton of projects in the world right now that are called the Connectome projects, where they're basically going and they're trying to map every kind of synapse and connection in the brain. And they might take a millimeter of my math is usually terrible. The small section, how about that, of the mice brain, and with the microscopes and the things that they have now in the computer programs, it might take them 3 months to do this microscopic amount of the brain of 100 million connections or a billion synapses, and it might store 2 petabytes. The thing is, that's going to accelerate in the same way that if you think about the same movement of gene technology, right, where it spent billions of dollars and well over a decade trying to sequence one human genome, it accelerated all the technology to do it. Now you have a machine, you just spit in the glass and it'll do it for $100 and sequence your whole genome in a couple of hours, right? So that technology of people studying the human connectome, so we can essentially simulate the brain, right, or simulate all the connections in the brain. I think that happens in the next decade to 15 years, right? And the processing technology catches up with it. Maybe a combination of quantum, and maybe you don't even need to get to quantum. You just need better specialized chips to get there. At some point, we can kind of maybe watch, a simulated brain doing things we do, and we just go, well, this section's lighting up and this section's lighting up. Cool, let's figure out the math behind that. Right, and then just copy the math. So there's a possibility, right? We don't have to actually, reverse engineer what we do. There's a chance we can brute force it too. So these are the kind of multiple pathways I see towards this happening. Again, 10 years, maybe, but certainly. I think it's possible. I think it's going to happen in my lifetime. Certainly, the next 20 or 30 years. But again, give or take margin of error of 30 to 100 years.
Yeah. Or it's like the humanity is still a blink of an eye in the whole age of the universe, right? So, no, I
Yes.
agree. I think that's fascinating to hear you play that out. And in terms of AI in general, right? There is this multiple camps here, and you're right about the fact that you don't need, and I like to say that you don't really need artificial general intelligence to really get into a doomsday scenario either, which we'll talk about in a little bit. You just need, good enough AI with the correct human effort associated with it in cohort to make leaps of progress, if you will, right? So, and it's a great example. So, coming back to today, where is AI today? Is organizations really realizing value? Where are they getting stuck? What do you see?
And to me, it's mostly just sitting with the big tech companies and like militaries and the most cutting edge organizations on the planet. Um, you do see it in some small startups that have just decided to go all in on the technology, something like Stitch Fix,
Mm-hmm.
where they basically just doubled down, hired a bunch of folks, and they do a bunch of great stuff. Like they made data science the center of their thinking, and they built all their own infrastructure to do it, right? It can look at a customer's Pinterest and realize that she likes blue dresses and recommend more of those, to her. It can do intelligent routing based on like where the person is and only show the things that are in stock in, the closest manufacturing facilities or warehouses, right? It can do sentiment analysis on the requests that are coming in and try to prioritize them based on, well, this person seems pretty angry, right? Or this person, can probably wait a little bit. These kinds of things. So that's going to accelerate, right?
Mm-hmm.
And in those cutting edge organizations, but it's really cutting edge organizations, right? Right now, you have the Googles, Amazons, Facebooks of the world. They have the might and the power to basically write all of the infrastructure software, hire all the best like data scientists and researchers who were pariahs for many years, right? They told these folks that don't study us, it'll never work, right? And so you have a small cadre of folks, right? You're getting more and more now because now everyone realizes, oh, it actually does work. But you had a small group of researchers who kind of kept the torch burning for many years. They've hired up all of those folks, and they've got the ability to spend $10 million on a transformer, or $20 million to study a game, right? And build a neural translate engine, right? And replace their old engine. The average company doesn't have that. And so what we're starting to see is this kind of Cambridge explosion
Mm-hmm.
of small AI infrastructure companies, right? So, that's why I have the AI Infrastructure Alliance, 50 plus companies and communities coming together, the whole spectrum, everything from, data lineage, data versioning to pipelining systems, to experimentation engines, to feature stores, to monitoring, logging, bias detection, everything, right? All these pieces are kind of like ill formed. They're coming together slowly, right? And so what I feel is you end up having you need to have kind of robust stack that the average companies can build on. They're not going to roll the old infrastructure, right, and hire the data scientists and do this stuff. You also need to see a lot of the data science to start to kind of like progress enough that more of it is applicable by everyday programmers, right?
Mm-hmm.
Programmers can add and adopt these things. Once there's like the O'Reilly book 5-10 years from now for the 5 ways to do baked image recognition and text analysis, right? It's that, and it hasn't advanced for a few years. That's where you start to see kind of regular programmers do this. So the infrastructure needs to get there, and then you start to get that kind of what they call that WhatsApp effect, right? So WhatsApp had 35 engineers, and they built an app that reached 400 million people. Now, give them if they had started WhatsApp 10 years before that, 0.0% chance they could have done it without a massive team, because they would have had to research, like they would have built their own GUI and their own, roll their own kind of like messaging protocol and transport layer security and all this. So they were able to take all these big standards and piece them together into a brilliant new app. And that's where we need to get to. We're still at the point where it's still early adopter on the diffusion innovation curve, coming out of the big giant companies and starting to come down to the smaller tech company and the smaller enterprises, right, for key applications. But you're going to see more and more of that infrastructure solidify in the coming years, right? And then people are going to start to be able to forget about the infrastructure, build amazing things on top of it. You're going to get billion-dollar unicorns out of that space, right? And then people start to move up the stack and do really interesting things. When the average person doesn't have to know anything about that kind of stuff, and there's sort of the Photoshop of this space, right?
Mm-hmm.
It's like Photoshop is an advanced tool, right? But if you want to learn Photoshop, if you're a kind of dedicated, person, you can figure it out by dragging around, playing with it, doing a project yourself, right? Right now, that would be nearly impossible for the average, programmer to do in this space, right? And that's where we want to get to.
So is it, so there's, I hear two things, right? One is there's a talent issue, right? Wherein the all the talent is now scooped up by the top 1% of companies. I'd like to say AI has a 1% problem today. And then there's a tools and infrastructure issue, wherein the reason all those talent, again, you think about it, all these data scientists don't really even know about the infrastructure they need, right? There's someone else building it for them, right? So, but that even building and maintaining and running that infrastructure is a hard problem to go solve. It's an engineering problem to solve. So on one hand, you're going to have the infrastructure being like things like the Canonical Stack, where you have like a much more higher level of abstraction for everybody to work with. So that in turn will have the effect that you don't need to have this complex organizations to actually build their infrastructure from scratch. But on the talent side, I'm hearing that look, there is a dearth of talent. A lot more people are coming in, but they don't have the pedigree. They haven't done data science for the last 10 to 15 years. Is this kind of an approach also going to solve that problem? Can they really? Because data science problem solving is a different skill set than maintaining and deploying an AI infrastructure to run a data science solution, right?
I think it makes it easier, but the fact is that the problem solves itself, right? As soon as something becomes more mainstream and people start to see it's an exciting field and has a lot of potential and there's good earning potential and there's all these types of things, then people start flooding into that, right? And intelligent people start to flood into it. And so from my standard, more and more people are starting to train these data scientists, right? They're learning about it in schools. They're playing with it on their own. You've got great programmers who are moonlighting and making a transition into it. You don't just have to learn it in school. You can be, this industry is still very self-taught. And I always love when in industries like that. So I think that problem solves itself, right? Again, is a lot of these folks, you have to understand there were multiple AI winters where there was a lot of hype and then the AI really didn't match up. People got ahead of themselves.
Yeah.
They predicted what it would do, but the data sets weren't there. The processing wasn't there. So, I still have a whole collection of old artificial intelligence books, right? Going back to the 50s and then through the 60s, 70s, 80s, right? And a lot of the techniques are still the same. I mean, they're talking about, neural nets and trying to simulate a synapse and, all these kinds of things. The problem is it wasn't like theoretical physics where you could just say, okay, we know the math works, but, we can't quite prove it yet. The problem is in computer science is a very hands-on thing. You have to, show me the output, right? And so just because we didn't have you were like, well, I know the neural net math works. Well, that's great, but it's just a toy, and it basically can't do better than a hand-coded logic system at this point. So what's the point? So it took kind of the rapid evolution of GPUs, right, and these huge data sets that came from the internet, that beautiful convergence of things, for these techniques to come out. And you get AlexNet really in 2008, not that long ago, right? Hand-coded CUDA running on GPUs that all of a sudden smashes the old standards. Like the best image recognition systems at the time had 70-something% accuracy, right? Huge, horrible, right? All of a sudden AlexNet comes in and has something like 80+%. And people are like, whoa. And you look at the dots on the graph, that there was only one neural net that year. In 2009, 90% of the entries were neural nets, and now it's like 90% or 89%, right? And after that, there's not a single hand-coded system. Within 4 years, it was better than humans. They had to shut the contest down. So you see these kind of huge leaps after you reach a convergence of lots of different things, right, that happen. And so I think now that there's enough people who want to study this stuff, that over the next 10 years, it really resolves itself. And you're going to have plenty of people who want to work in this, everything from the top-notch folks all the way down to what you call a blue-collar AI programmer, in my opinion.
Awesome. So what is the Canonical Stack for AI, and what's the AI Infrastructure Alliance? Tell me a little bit about that.
Well, the Canonical Stack doesn't fully exist. I'd say that the AI Infrastructure Alliance is designed to kind of bring it into being, right? And so there are 50 plus companies. It keeps growing every day. I'm losing track. Could be 100 by the time you listen to this, or 70. But these are all these companies that are a lot of the companies kind of came out of different companies in the past, right? So Pachyderm came out of a bunch of companies that were doing fraud detection, and they were trying to solve these problems. They had these huge pipelines that ran with 60 stages. They would take all night to process, and one stage would go wrong because a programmer changed a URL or whatever, and the whole thing would grind to a halt, and they'd spend all this time troubleshooting it. So Pachyderm came out of trying to solve this data lineage, data versioning, and these agnostic pipelines along it. Tecton, the folks came out of Uber. They were part of Michelangelo, and they invented this concept of along with Molecular, which is a company you were a part of, right? The idea of a feature store, storing these kind of structured data solutions as different teams are working on it and being able to share those features rather than every team kind of recreating the same feature and sharing those costs. So they thought, well, maybe we could abstract this outside of it. They found Michelangelo actually wasn't very flexible. They built their own architecture, right? They're one of the companies that could do it.
Yep.
They found it wasn't very universal or flexible. So what you're starting to see is all these folks are kind of like, wait a minute, there's an abstract problem. I can start to take this iteration and turn it into an abstract solution. And so you have all these companies kind of betting on this different thing, open source projects, right? What we're trying to do in the AI infrastructure alliance is get them talking to each other, get the engineers, salespeople, everyone collaborating, not trying to solve everything in a silo. And also saying, like, we don't believe the big companies that they've got the end-to-end solution. That's all nonsense. It's marketing. They don't. And it doesn't matter if they have, $50 billion valuation or what. There's no end-to-end machine learning platform. Don't believe the hype, right? So we believe it's going to be Lego bricks to stick together. And when Amazon rips out their feature store and plugs in, Molecular or Feast or Tecton, we'll know the AI has won. And that's how it always happens, right? The proprietary engines come out, right? They have a huge advantage. The programmers, they can make it pretty, right? And it's more integrated. The evolution of the wider system is slower. It's a bit uglier. It's messy. It's like you got to use the command line. What is that, right? And all of a sudden, though, that engine over time starts to get more and more robust, right? Bypass all the features, blow past the features of the proprietary version, and eventually they're ripping it out. Same thing. Take a look at something like Kubernetes, right? Mm-hmm. Where all these people are making orchestration systems, right? Betting their whole careers on this thing. And Kubernetes had come out of the evolution of Borg and Omega and 10 years of work, started getting mass following, and all of a sudden any company, right, that was like building their own thing, all of a sudden you look at their marketing now and they're like, we've always loved Kubernetes since the beginning of time, right? Like the great leader, right? We've changed history. That's how it happens, right? And so we believe that stack, we want to foster the technical projects that are glue frameworks, interoperability, right? Working together, right? We don't need to have another feature store project in there or another pipeline. We got 4 feature stores, right? We don't need another pipelining system. We got 10. What we need are abstractions, glue frameworks, deployers, day 2 operations for these kinds of things. That's what we're looking to foster, and we believe that's the fastest way. Let multiple stacks compete. We're not trying to take the kind of open stack approach, right? Where you define one standard. By the time you're finished with that standard, where you're trying to satisfy 200 people, you're not going to hit the thing and deploy 50 solutions in the IA, right? You're going to have 3 or 4 of those things in there. So our thing is let multiple stacks compete, right? Think of it as a bazaar instead of the cathedral, right? That's the open source approach, right? Everyone starts equal, but then the spice dealer, the scarf dealer, the hat dealer start making a deal with each other to have 10% off in each other's stalls. All of a sudden you have this conglomerate that's working really cool together, right? And then all of a sudden you have multiple giant groups within the bazaar that understood the value of working with people, playing nice in the sandbox, building integrations, and all of a sudden the stack emerges from the garden. And that's really what we're hoping to achieve.
That's amazing. You're really putting in the seeds and setting up the infrastructure for the industry to evolve into that future you described earlier, right? How do you really bring in the refinement and the industrialization of AI projects and make it accessible for everybody? That's awesome.
That's right.
So you and I both know a lot of organizations that are mostly, they've started with AI, they've done some efforts, they're trying to scale it. What advice do you have for those organizations who have started with AI? They believe in it. They've actually gotten a lot of buy-in, but they're really still kind of stuck. They want to make progress today. What advice do you have for them?
The same progress in everything. It's crawl, walk, run, right? It's people try to get too ambitious too quickly, right? Really understand what problem you're trying to solve, right? Identify all the problems you'd like to solve or that you believe machine learning could be beneficial to you. Then, go out and study it. Look at, has anyone else solved that problem, or do they think it's possible to solve that problem with that? Then categorize those problems into low-hanging fruit, moderately complex, and very complex, right? And then start to build a system that like is going to get you some early wins, and then move up to those medium technologies, and then go for the moonshot after that as you got your kind of like sea legs under you, right? But understand clearly what it is you're trying to achieve. Don't just hire a data scientist and like expect him to bring his own architecture on his laptop and hope that that's going to work, right? Hire a team to solve a real problem in the real world, but understand, has anyone made progress in this, or does it look possible to apply the current state of the art to one of these problems? Talk to different people, talk to different data scientists, talk to different organizations, do the research yourself, find out who's already working on these things, and see how far off you are. Then start working at it from that angle. Have a real problem to solve, right? It's kind of like, I want to write a novel. Okay, well, what kind of novel do you want to write? There's a lot. That's a lot. Is it sci-fi? Is it a self-help book? Is it, is it a personal, a personal story? Is it fine literature? What is it, right? First of all, and then from there, start defining the rule sets of that, right? If you think sci-fi, my favorite answer to that is it's not about what's allowed in the world. It's about what's not allowed. You actually start, like an amateur writer is like, everything's possible. The advanced writer is going to start to say, look, here's all the things that are not possible. Okay, this is a sword and sorcery fantasy. So there's no blasters in this. Cut all that out, right? So you want to really narrow down the scope of the problem and start really getting to like, hey, these are the criteria. Give yourself enough room to move around it, but define the scope of the criteria. Take it seriously, and also take the idea that things could go wrong seriously from the very beginning. Build yourself an AI red team. Build yourself a team that is looking at trying to build unit tests and trying to break the thing, looking for bias early. Don't try to cobble together a system later. Really try to understand how you can validate that the model works from the very beginning too. Think through the whole process. In other words, once again, it comes back to my favorite thing in the world, critical thinking, right? And understand what it is you're trying to do before you do it.
That's awesome. I like the Cliff Notes version of this is me phrase like crawl, walk, run, treat AI like science fiction. I love that. Actually, I'm going to use that in a bunch of places. And have a red team. Have the guys, cybersecurity guys, do it all the time. Break it. Try to actually do it, and bring that critical thinking into the aspect, and then you can actually approach things like trust and bias and fairness and
Right.
adversarial robustness and things like that. So this has been awesome. So I got a couple of rapid fire questions for you, and then we can wrap up. We're running out of time. One is AGI. Do you believe the artificial general intelligence is going to exist in our lifetime? Like you kind of alluded to that when you were painting out the picture of the future. And what do you worry about that?
I try not to have beliefs, because I believe beliefs are the death of intelligence. So I try to have strong opinions weakly held. I believe once you have a belief, what you try to do is then defend that belief against all new information, or force that information to fit into the belief. Right. So I'm always trying to expand it and go. So I would say if I have a belief about AGI, it's maybe in our lifetime, but or at least an approximation of it at some level. It definitely happens, right? We're a generalized intelligence. There are other generalized intelligence. A squirrel is a generalized intelligence. And, there are all kinds of generalized intelligence. If you don't think a squirrel is very intelligent, try to keep it out of your garden and see what happens, right? So it's optimized to get into that garden. So it definitely happens. Maybe not in our lifetime. But there's no question that we can simulate what it is to have a generalized intelligence.
What worries you about it, or does anything worry you about it?
Generalized intelligence doesn't worry me in the least. Narrow intelligence in the hands of selfish, vicious, angry, sadistic humans makes me more nervous. Humans don't need any help being jerks. Historically, we've done all kinds of horrible things, and AI will just augment it. AI is just a tool. It is a tool, and it is I have a lamp, and I can light my room, or I can pick up the lamp and knock you over the head with it. Right? It's all in the hands of who has that tool and how they use it. And I very much worry about something that obeys 100% rather than something that can think for itself.
That's very fascinating. If someone is starting with AI today, they want to learn machine learning and get into AI, what's that one resource you would recommend for them?
Man, the internet, right? I mean, like YouTube, right? I mean, there's so many. There's a billion resources out there. I mean, I wrote the Learning AI is you suck at if you suck at math. I wrote a 7-part, 8-part series when I was learning it myself, and that was just me as a systems person trying to figure out, well, can I learn this stuff? I didn't have a huge math background. I mean, is it possible, right? And I wrote the articles as I did it, and it was all my experiments. And you don't be afraid to go in a direction and be wrong. In other words, learning is about making mistakes, right? Start in any direction and be like, just be like a reinforcement algorithm. Like, you know what I mean? Just start course correcting,
Feedback.
right? The closer, the more you're wrong, right? There's an old saying in Go, if you want to learn Go, first lose 100 games really fast, right? And that's really what it's about. And same type of thing. Go out there, research a bunch of things, try things, do some stuff at night, and follow your passion in it too. Don't just go, well, cool, can I do an iris data set? Yeah, do that. But if you're interested in art or things like that, like go start studying what people are doing with music or imagery with it. You know, if you follow your passion in the thing, 10 years from now, Adobe or one of the movie companies is going to be hiring you because you spent your nights working on that rather than figuring out AI and how to make people click more ads. So go with your passion and do things that you think are really interesting. And that's where I think that the best things in life come out of.
That is awesome. You should send me as a follow-up, the 8-part series that you wrote. I have a lot of
Sure.
friends who actually are in the same boat. Like, I suck at math. I want to learn machine learning. So I'll put it in the show notes.
Okay.
It's been a blast. This has been a blast. How can the viewers and listeners get in touch with you, Daniel?
I mean, easiest thing is on Twitter. You follow me on Medium. So I think it's Dan_Jeffries 1
Yep.
on Twitter. And it's remember the number 1 because I think Dan Jeffries there's a Dan Jeffries who studies the asexual reproduction of tree frogs, right? So we've had some fun back and forth. So I think remember the number 1 after it, but you can, if you Google Dan Jeffries, Learning AI if you suck at math, Dan Jeffries Artificial Intelligence, you'll find my Medium, which is medium.com.
By the way, did anybody
at
ever?
Dan Jeffries.
Thank you. And did anybody ever reach out to you asking for counsel on reproductive systems of tree frogs?
No, but they reached out to that fellow a ton of times asking her about crypto, artificial intelligence, writing, futurism, science fiction. And he said, you have to go talk to the more famous Dan Jeffries. I'm sorry.
That is awesome. Daniel, this was a blast. Thank you so much for taking the time today. And it's been great. Thank you.
Cheers, man. Thank you so much for having me on.
Thank you. Bye-bye.